Hello, so today we are going to have a look at finding points of intersection when your function is being expressed as a parametric or a set of parametric equations. So here I've got an example for you. So a curve is given parametrically by the equations x equals t squared and y is equal to 4t. The line x plus y plus 4 equals 0 meets the curve at A. Find the coordinates of A. So I'm just going to talk through what strategy you'd use to try and solve this. And the first thing that I'd like to just draw attention to is the fact that you're given an expression for x here, and you've then got an x in the line that is meeting your curve. You are given an expression for y here, and you'll see that you've got a value for y here again in that line. So quite simply, what we're going to do to begin with is to substitute for the values of x and y. So if I were to write this out, I've got x plus y plus 4 is equal to 0. Substituting in the value for x then, I will get t squared instead. Substituting in the value for y, I'll get plus 4t. And then plus 4 is equal to 0. So I've just quite simply made a straight substitution, and now you'll see what we've got is, well, a quadratic expression, but it's given all in terms of one variable, and that is the variable t. So if I go ahead and factorise this now, I'll actually find with this that I've got repeated roots, because it factorises to give me t plus 2 in both cases. So that means the value of t, where the curve meets the line, is going to be when t is minus 2. Now, you haven't actually finished answering the question at this point. Yes, we've worked out what the value of t is, but if you go back to have a look at the question, it's asking you for the coordinates of A. So to get those coordinates, we're going to go back to the original sort of parametric equations and work out what those values could be. So if I move this up just a little bit. So given that t is equal to minus 2, when t is equal to minus 2, x is going to be minus 2 squared, which will give us 4, and y is equal to 4t, as we can see up here, so that's 4 times by minus 2, which gives us minus 8. So the coordinates of this point A is 4, minus 8. And there we have it. We found the points of intersection. And here I've included just a diagram of what this looks like, so you can see that point of intersection that you found. So if you have a look over here, this is the equation, or sorry, the parametric equations here. That's generating that red curve. This is the line, and the 4 minus 8 is sort of in this region here, where the two of them have intersected, or in this case they just touch. Okay then, so here is a second example which looks slightly more intimidating when you first have a glance of it. So the diagram shows a curve C with parametric equations. So x is equal to cosine of t plus sine of t. Y is t minus pi over 6 all squared. And that t, so the actual domain for the parametric equations, is that it is restricted to being between minus pi over 2 up to 4 pi over 3, or 4/3 pi. So the first part is asking us to find the point where the curve intersects the line y is equal to pi squared. Again, it looks a lot more intimidating than it actually is. Start by having a look at your line, or your sort of intersection, and look at what values you've got. So here I've got an expression for y, but for my parametric equations I also have an expression for y. So I'm going to begin by making a substitution for the y into the equation. So if I have that y is equal to pi squared, it follows then that t minus pi over 6 all squared is equivalent to pi squared. So if I start by taking the square root of these, what I will find I get is the following expression. So t is equal to, not equal to, t subtract pi over 6 is going to be equal to positive or negative value of pi. So finding the point where it intersects, t is either going to be pi plus pi over 6, which is equal to 7 pi over 6, or if I take the negative value, remember the little cat looking really sad if you forget about it with the positive and negative square roots, minus pi plus pi over 6 is going to leave with minus 5 pi over 6. Now, if I can just draw your attention to these values, if we go back to have a look at the question, and again pay particular attention to this part here where it talks about the input values that we're allowed to have, what you should hopefully recognise is that this second root that we've got, the minus 5 pi over 6, is actually outside of the range. So we're going to discard that and just focus on this 7 pi over 6. Now again, the question has asked us for the points of intersection. All we've calculated here so far is the value of t. So we need to substitute the value of t back into the equations for x and y to generate our x coordinate and our y coordinate. So here are the parametric equations with the value of t substituted in. So here is my x coordinate here. I've substituted in the values, or the value of t, which was 7 pi over 6, and that generated this answer for me here. And then for y, again I've done the same thing, substituted in the 7 pi over 6, that's generated this expression here, which cancelled down to give me pi squared. Do remember with these that you are working in radians, so you need to make sure that your calculators are in radians. And here, if you got an answer slightly different to this minus 1 plus root 3 over 2, just double check to make sure that it hasn't just been a case that you've rationalised the denominator. So if you have a surd in your denominator, you should multiply to get rid of that. We only allowed surds in the numerator of the questions. And again, here is a diagram of the parametric equations against that line, so you can see your point of intersection. So a couple of things to notice: look at how that red line just stops abruptly in midair at both ends. And well, I called it a line, it's a curve. The reason that it obviously stops is that we've got the restrictions on our domain here. So that means that this is the only region in which that graph exists. If we change those parameters, then we'll be able to extend that curve or reduce it. And then here, pi squared, so we're thinking about 3.14 squared, comes out there as 9.869. So this is the section where we've just calculated the intersection point. So to go back to our previous work, that intersection point is this region here. Okay, and here is the final example for today, which is just looking at something where there's an extra element of workings out to do. So in this case, we're given the parametric equations where x is at squared plus t, y is a, brackets, t cubed plus 8, and we'll notice that currently we've got an extra variable that we're going to have to work out this a value. You know, we're used to having the t, but not necessarily having another variable to work out. So this question is presented a little bit differently, but it isn't very difficult at all to solve. We know our coordinates along the corridor up the stairs, so that means that this first coordinate, minus 4, represents the value for x, and this second coordinate of 0 represents our values for y. So what we will be able to do to calculate the value of a is substitute those in. So this is what we'll get when we substitute in those values. Minus 4 is equal to at squared plus t, and 0 is equal to a, brackets, t cubed plus 8. Now I'm going to take this second one here and work with that one. We are told in the question, it's quite an important point that you'd probably skip over if you were just skimming the question to start with, but we're told that a is non-zero. So here, in this expression, I've got a multiplied by something, giving me an answer of 0. That must mean that this section, the t cubed... Okay, so there we have it. If a is non-zero, then the t cubed plus 8 part must be equal to 0, because when I multiply two things together, that's the only way to get 0. So, moving through this then, t cubed is equal to minus 8. So t would be the cube root of minus 8. Now I'm not going to get positive and negatives when I'm taking the cube root, so it follows that t is just minus 2. Once I've got this, I can now use that in this expression here, in my first expression, to help me work out what the value of a is, because that again is still what we're trying to do. So minus 4 is equal to, so a minus 2 squared plus minus 2. So I get minus 4 is equal to 4a minus 2. Okay, so adding 2 to both sides, I'm going to get minus 2 is equal to 4a, and so a is equivalent to minus a half. So there we have it. Final answer, a is equivalent to minus a half. So let's go back now and have a look at what we need to do for part B. So for part B, find the coordinates of the points A and B where the curve crosses the y-axis. Okay, so let's have a little think about that. When we have the curve crossing the y-axis, okay, so imagine, because there are 2 points, let's say it's something like this. When we've got the y-axis, it follows that x is equal to 0. So that's going to be my starting point for this question, is setting x equal to 0 and trying to solve from there, now that I've got this value of a. Okay, so here is the expression that I was given at the very beginning. Okay, what I've done then is substitute in the value of a, because we found out in part A that that was equivalent to minus a half. And then I've got the second part where I have made x equal to 0, following this idea that if it crosses the y-axis, x must be equal to 0. So let's try and solve this equation now. So to begin with, what I'd notice, so we'd factorise it and just get a single bracket because we've got a t common in both parts. So it must follow then that either t is equal to 0, or this minus a half t plus 1 is equal to 0. So minus a half t is equal to minus 1, and therefore t is equivalent to minus 1 divided by minus a half, which would give us 2. So those are the two possible values for t. And again, what we've got to do now is put those back in to find the actual coordinates, because we've only found the values for t. So when t is equal to 0, my x coordinate is going to be... Okay, so substituting those in, you get x is equal to 0, because t squared plus t squared is 0. I should have known that really, because when we're working out on the y-axis, it is given that x equals 0. And the value for y when I substitute in t is equal to 0 is minus 4. So that's the first coordinate of where the curve first intersects the y-axis. And then the second point, we substitute in the value that t is equal to 2, and again you should just get standard that x is equal to 0, and for y we get minus 8. So that's my final answers given there in terms of those two coordinates. And again, here is a diagram so you can see what that curve looks like. So I've put in the parametric equations here. It could be any of the real numbers, but I have just put in minus 100 to 100 for now on the domain, just to sort of get this little sketch up. And you can see that those intersection points with the y-axis are exactly as we thought. So you've got minus 4 here, 0 minus 4, and 0 minus 8. So well done us. Thank you.